Hi, today we're going to be talking about section 2.6, special functions. We're going to be talking about the piecewise defined function, the step function, and the absolute value function. A piecewise function is basically just two functions where we're going to split a domain. So if you look at this, this says the graph of f of x equals x plus 2 if x is less than 0. So that means anywhere to the left of 0. So a domain 0 or from negative infinity up to 0, we're going to graph the line x plus 2. But then underneath it, it says the graph is then x if x is greater than or equal to 0. So for the domain 0 up to infinity, we're just going to graph the line x. Okay, so if we graph the line x plus 2, it's going to go, like we said, from negative infinity up to 0, right? Let's see, if we plugged into 0 this equation, it would 0 plus 2 is 2. So if I know each of these dashes is worth 1, it says if x is less than 0. So I'd have to have an open circle here at 2. Okay, and then the graph, if you think about this, it has a slope of 1, y equals mx plus b. Well, there's nothing in front of x, so we know the number is 1, so the slope is 1, the y-intercept is 2. So I graph that y-intercept at 2. And a slope being 1 would be rise 1 and then go to the right 1. Or to go backwards, we'd go left 1, down 1, left 1, down 1, left 1, down 1. So we're going to go to this point, this point, this point. That's a slope of 1. So I've got something to trace now. I'm going to draw that slope there. Okay, put a little arrow on it. Make sure you use a straight edge to make me happy. Okay, and then for the bottom part, it says for x is greater than or equal, we've got the equation y equals x. So we know that has a y-intercept of 0 because it was just x, and then also has a slope of 1. So it's just going to follow these lines up here. Okay, so notice we have a break in that graph there. It jumps down, like it's going up, but then it stops and it jumps down because we don't have the plus 2 anymore. So that's what a piecewise function looks like. That's a very simple one, and they have the same slope here, but that won't be how all piecewise functions look like. For example, here's two others. Okay, but we're going to actually take these and we're going to try to find the equation. So I'll do the first one, you'll do the second one. So we can see here, these have been broken into 3 sections. So I think it's easiest to start off with defining the domains for each of the sections. So I'm going to say f of x is equal to, and then put your little bracket. Okay, and I'm going to know that over here I've got, this is for this piece of the line here. That's from negative infinity up to that, and including, that looks like a negative 3. So I'm just going to define that off to the right here. This is for x less than or equal to negative 3. Okay, for the second part, that's going from negative 3 up to 1. So we would write that as negative 3 is less than x is less than 1. And then for this line here, I'm going from 1 up to infinity. So I'd write that as x is greater than or equal to 1. Okay, so now I just need to figure out an equation for each of these 3 lines. Okay, so if I look at this first line furthest to the left, all right, I'm going to say it hits right here at that point and that point. So this point here is at negative 6, 0, and this point here is at negative 3, negative 1. So I'm going to use those. I'm going to make a little slope triangle. That thing goes down 1, over 1, 2, 3. Okay, so negative 1 over 3 is that slope. So slope there is negative 1 over 3. Okay, so that's my m. Okay, If I continued that over another 3, I'm going to go down another one, and it would actually cross, if I continue that line, it would cross my y-axis at -2. So I know my b value for that line is equal to -2. So my first equation would be y equals, well, we've already got the f of x. I don't need y. Sorry about that. We've got f of x equals already. So we just need to write it's -1 over 3x minus 2. So that would be that very first one. Okay, the second, or the middle part, okay, it has a slope of 0. We can all look at it and say that line is perfectly horizontal. Okay, it also has a y-intercept of 2, so it would be 0x, which is just 0, plus 2, so it really is just y equals 2 as our equation. So that one is just a 2 here. Okay, and for our third, this part, okay, I'm going to make another slope triangle. I know it hits that point, and then it goes up 1, 2, 3. So that's a delta y equals 3, and my delta x equals 1. So it's up 3 over 1, so that would be m equals 3 over 1, which is just 3. Okay, if I was to keep going, that was up 3 to the right one. If I go down 3, left 1, I'm going to hit right there at 0. So b for this one is equal to 0. So this equation would just be 3x. Alright, so I've got my 3 equations. You usually put a 4 in between these, so the equation is -1/3 x minus 2 for x less than or equal to -3. It's f of x equals 2 for -3 is less than x is less than 1, and it's 3x for x is greater than or equal to 1. Okay, so there's that one. I want you to hit pause now. Try to come up with the piecewise function for this graph. Hit pause. Okay, hopefully this is what you got. That first line to the left, which is from -infinity up to -1, would be 3x, but it's an open circle, so it's not including 1, so it's just x is less than -1. From from -1 up to 3, we have the line y equals -x, and from 3 on to infinity we have -x plus 7. You can see those two second lines have the same slope. They're parallel, but they have different y-intercepts. One intersects at 0, and one, if you were to continue, that would intersect up at 7. So hopefully that's what you got there. Okay, step functions. So step functions, again, a lot of times it's not realistic to have, for example, you can't have halves of certain things. So a step function, like if I was trying to plan how many different sections of Algebra 2 we need, all right, well, we can fit 30 students into a classroom, so if we were filling these up, you would say, okay, as numbers start coming in, you'd start with all from 0 students up to 30 students, you'd have one classroom. But as soon as we get to 31 students, you need to bump that up to 2 classrooms. So then from 30 up to 60, you'd have 2, from 60 to 90, you'd have 3, and so on. So that is a step function. What that looks like on a graph is, if we were doing something like this, we'd go from 0 up to that 30, we'd have that number, then we'd have from that new number up to the next number, a new one, so it looks like it creates the steps. You have these different lines going up as steps, and then it depends on which side that you have the open circle and closed circle. So here's an example. I want you to try to create a step function for this. A recycling company pays $5 for every full box of newspapers. In other words, they're not going to pay you $5 for a half full box. It has to be a full box of newspapers. They do not give any money for partial boxes. Draw a graph that shows the amount of money P for the number of boxes brought to the recycling center. Okay, so go ahead and hit pause and see what you come up with, and we'll see if I get the same thing. Okay, first off, it said to draw this in terms of P of X. Okay, and this is number of boxes. Alright, well, let's go 1, 2, 3, 4, 5, 6, 7, 8. We'll go up to 8. Okay, well then we need to go 5, 10, 15, 20, 25, 30, 35, 40. So we'll say it's 10, 20, 30, and 40. Okay, well, from 0 boxes all the way up to, but not including 1, so we'd go from 0 up to, but not including 1, we get no money. Alright, but as soon as we've got to 1 full box, so we'll close the circle, as soon as we get to 1 full box, we jump up to $5. And we're going to make $5 all the way up to, but not including, till we get to 2 boxes. So that would be that next step. Then from 2 up to not including 3, we'd have that. From 3 up to, but not including 4. From 4 to 5, 5 to 6, 6 to 7, 7 to 8, and so on. So that's what your step function would look like. Something like that. Clean up your circles, you know, make them a little bit nicer. Again, on an iPad it's hard to draw these. It's a lot simpler on a piece of paper. Okay, so that's what a step function looks like. That's what this function would look like specifically. Okay, an absolute value function. We talked about what an absolute value is. If you don't remember, it's just the distance away from 0. A great way with any function to figure out what it's going to look like is just plug numbers into a table. So let's start from -2, -1, 0, 1, 2, 3, 4. See if that'll be enough for us. Okay, so these are our x values. There are independent variables. These are our f of x, also known as y, our y value. So if I plugged in -2, -2 minus 2, -2 minus 2 is -4. The absolute value of -4 is 4. Okay, if I plugged in -1, -1 minus 2 is -3. Absolute value of -3 is 3. If I plug in 0, I'm going to get a 2. And then I'm going to get 1 minus 2 is still -1, but that'll be a 1. 2, I get to 0. Okay, and then at 3, 3 minus 2 is a positive 1, but still a positive 1. So we're going to go back up to 1. And then 4 minus 2 is 2. Absolute value of 2 is 2. And it'll continue that pattern. So it went 4, 3, 2, 1, 0, 1, 2, 3, and it's going to continue on. So if I was making this graph, alright, I would go, okay, if that's -2, -1, 2. For our y-axis, we'll just go up 1, 2, 3, 4. Okay, so -2 is at 4, -1's at 3, 0's at 2, 1's at 1, 2 is at 0, then 1, then 2, and if I was to continue this, it would go up, back up to 4. So the absolute value function forms what looks like a V. Oh, I missed a little there. But that's what the absolute value function looks like, and it's shifted 2 to the right. Normally it hits the origin there, just the regular parent function, the absolute value of x hits here and it makes a V here, but that -2 shifts it to the right too. Okay, so you try this next one. Go ahead and hit pause and see if it's the same thing that I come up with. Okay, hopefully that's what you came up with. You can make a table and plug them in, or you can use, if you know, a negative sign in front of the absolute value or outside the function is going to flip and make all the y values negative, and that +1 shifts it up 1, so it really reflects it over the x-axis and then shifts it up 1. So that's how you get to that graph if you don't want to make a table. Bring in any questions that you have. We're going to practice some of these, and this will lead us into, especially this one, will lead us into parent functions and transformations in the next section. Thanks.